Hello, everyone. Welcome to this talk about best practices that we have learned in Google Production Security and how we can apply them with Istio. So the focus for today's, one of the focus for today, we will talk about how the production landscape is changing, right? What is its impact on network security, and why Google's approach is actually increasingly relevant and now more approachable than ever for the enterprise. And Istio is a means to an end of achieving a security purpose, right? The key thing is to implement a set of key security principles that we have learned over the years to protect microservices infrastructures within Google's production. And that's what we will talk about. And I am Samrat Ray. I'm a product manager on Google Cloud's security and privacy organization. And my focus is on service security and insider threat. With me is Julien Boeuf. He's the network security lead for Google's production. And I think this session is special in the sense that you get to hear from the people who actually build this stuff, which is Julien, right? Versus the people who generally talk about it. So, so with that, without further delays, I'll hand it over to Julien to start explaining how he sees the threat model evolve with the changing production needs, and then talk about how Google production, the principles of Google production security that have informed our posture for over the last decade or so.
All right, thank you very much, Samrat. And hi, everyone. So production infrastructure is changing, right? And that has a big impact on security. So we are observing a number of trends from our customers and our partners. And there are like three major trends that I want to talk about. The first trend is the use of orchestration frameworks and containers. And the most popular of these orchestration frameworks is Kubernetes today. The second trend is the use of hybrid and multi-cloud, meaning that one workload may be in one environment on-premise and can move to another environment on a cloud provider. And the third trend is the adoption of microservices. So let's start with containers and hybrid. And I will have a big claim here is that IP-based network security is suboptimal. So your IP tables can only go so far. And why is that? That's because when you think about it, an orchestration framework is going to schedule containers on a pool of hosts, right? And the orchestration framework can kill the workload on a host, reschedule that on another host, and as a consequence, the IP and the host IP in particular doesn't have a lot of relevance anymore, right? These containers, also these workloads, they're ephemeral. They can be start and stopped very quickly. Now for hybrid, as I said, you will have a workload that starts on an environment on-premise, and then that moves to another environment, which is cloud. And when that occurs, you don't want to have to reprogram all your network policies because the subnet is not the same, right? And so what that means is that we need policies and access logs, like policies and access logs, they need to have a stable identifier for the workload. The other trend is microservices. And when you think about your old monolithic application, where like everything was integrated in one big binary, that monolith got exploded into a constellation of microservices. And as a consequence, calls, function calls that used to be local are now completely distributed over the network. And what that means in terms of network security is that your network is much more privileged now if you don't do anything about it, meaning that somebody who has a privileged stance on the network is able to be able to do much more damage than before. So we need a solution for that. The other point that I want to make around microservices is that they expose a lot of different methods. And let's take an example of a key distribution service, for example. This key distribution service is going to expose some methods that have very different security properties. One method call can be completely innocuous, such as a health check. You want to check whether the service is dead or alive. And you will have another call that is going to be rotate the master key. And this one needs to be really heavily protected. And again, what this means is that the policies need to be able to reason about these different methods and their different levels of privilege. So that means that the policies have to go way beyond layer 3 and layer 4. They have to operate at layer 7. So the good news here, to some extent, is that adoption of containerized workloads and microservices, that's what Google has been doing for the last 10 years. We've been doing that over a decade. And we have, in production, millions of microservices endpoints. And so we're informing our network security posture by a set of principles. And I'm going to talk about these principles now. So I'm going to start this part of the talk by a quote from Niels Provost. Niels used to be our security horizontal lead. And he gave a talk on production security in this very forum a couple of years ago. And at that time, he said, at Google, we are not pursuing a hard shell perimeter model. Instead, we really focused on pervasive defense in depth. There's another term that you may have heard about pervasive defense in depth, and it's zero trust security. So personally, I'm not a big fan of zero trust security because at the end of the day, you have to trust something or a set of things, right? If you go with an identity-based system, you will have to trust your identity provider, your identity issuance system. You will have to trust your network for availability in any case. So I prefer the term defense in depth, which I think is more correct. And you can see defense in depth along a set of dimensions. And a first dimension may be how to build your stack on a production machine from a hardware root of trust to a bootloader to an operating system to containers and applications. And how do you make sure that at each layer, what you're running is what you think is running? That's not malicious code. And that's one dimension of defense in depth. The other type of defense in depth that we can think about is along the network path and how you can have 2 layers of security. One that is at the edge of the perimeter, well, at the edge of the production network, and the other that is inside, within the production network. And since we don't have that much time today, we're going to focus on the second one, the network path. So the first principle that we have is that, so we need 2 layers. So the first layer is that you have to protect your production network at the edge, right? And proxies are the thing that provide this isolation. You can see on this diagram here, you have our customers, the blue and the yellow personas, going through the Google front end in order to invoke a service at Google. This Google front end is going to do a bunch of security checks. And you can see that if an attacker tries to attack us here with, for example, a denial of service attack, we can detect this attack and we can react appropriately through aggressive rate limiting, for example. Now, for workloads that are within the network, we ensure that these workloads cannot arbitrarily egress out to the internet, because that would be an obvious vector for exfiltration of data. So we have perimeter security here as well. And even within our corporate network, we make sure that in order to access the production network, we go through an administrative proxy. And you may have heard of Beyond Corp, which is something that we're very keen on. But there are sometimes some misconception about what Beyond Corp is about. So Beyond Corp is about the fact that being on the corporate network per se doesn't just give you access to the production network. There are a bunch of other signals that you need to take into account in order for you to have access to some privileged resources within the production network. And these things are, for example, what is the device from which you're operating this request to the production network? Like, is it a trusted device? Is it an untrusted device? Who is the person who is authenticated on this device? Is it a Google employee? Is it something else, right? And the admin proxy is the one that will, based on all this signal and the type of resource that you want to access in the production network, make the decision as to whether you can or cannot access the resource in question. The thing that I want to tell you here is that you don't stop there, right? You don't stop at the perimeter. Within the production network, you have to protect your workloads for all the reasons that we told about before with respect to microservices, for example. So how do we do that? The first thing that we do is that we use credentials-backed identities for all the entities on the network. And the entities are the administrators, the machines, and the workloads. And let me talk to you about ALTS, because ALTS is Application Layer Transport Security. It's also known as LOAS. And that is the system that we use to do this type of thing. So ALTS does two main things. The first thing that it does is that it provisions, rotates, and revokes all the credentials for all these different entities. That's the first thing that it does. But ALTS is also a transport security protocol, meaning that it's extremely similar to mutual TLS, and it's certificate-based and private key-based. So now, let's see how Alice, who is a site reliability engineer, can schedule a workload, which is Doodle front-end, on a production machine. So the first thing that Alice does is that Alice makes a request to the Borgmaster, which is our scheduler, our main scheduler for workloads. And she gives a description of the Doodle front-end workload. And she also says, I want this workload to run as the Doodle front-end identity. And she does that over an ALTS mutually authenticated channel. Once the Borgmaster receives this request, the Borgmaster is going to do two types of checks. The first check is going to be, does Alice have the right to start a workload as the Doodle front-end identity? The first thing, right? Can she act as this identity? And the second check that is going to be done is that, oh, but this workload comes with a configuration about the binaries that are going to be running, and do we have some information about the provenance of this binary? And that's called binary authorization. Once these two checks are cleared, the Borgmaster will then choose a production machine, a worker machine on yellow here, and will, through an ALTS channel, again, that is mutually authenticated and encrypted, send the configuration to the prod machine of Doodle front-end, along with the credentials for Doodle front-end. And now Doodle front-end can authenticate to any of the other entities that we described before. For example, Doodle front-end is going to authenticate to another another workload, which is going to be Doodle backend, through, again, an ALTS mutually authenticated channel. And from the Doodle backend standpoint, Doodle frontend is going to appear as the client authenticated entity. Another principle that we have is to use channel-bound credentials for authenticating services within the production network. So what is a channel? You can see the channel as a TLS session between a client and a server. And by channel-bound, what I mean is that the proof of authentication is only relevant within the context of this channel. So authentication credentials can be of two forms. One can be certificate on private keys, and the other can be bearer tokens. And you can see on the web that bearer tokens are pretty popular. But we believe strongly that they are the wrong choice for authenticating within your infrastructure. Why is that? Is that basically bearer token, by their very nature, can be replayed. And that is a big issue here, because you have Doodle frontend on one end, wanting to talk to Doodle backend on the other end. But that's not the only channel of communication that exists. Doodle frontend is going to talk to a bunch of different other services, such as the load reporting service, or the log service, or the name resolution service. And when that happens, you don't want the load reporting service or any of these services to be able to replay the bearer token of Doodle frontend to Doodle backend, in other terms, to impersonate Doodle frontend to impersonate Doodle frontend to Doodle backend. And what that means is that we really want channel-bound credentials. And so again, in Google production, we use ALTS, which is certificate on private key based, and that doesn't suffer from this big drawback of bearer tokens. Another principle is that you have to be able to grant access based on multiple identities. And that's not something that you can do with, like, again, policies just at the layer 3 and layer 4. Each service, each workload exposes methods and sometimes user data. And all this access may be explicitly authorized by policies. Now, let's talk about the different identities that we have here on the network, on the request path. You first have the workload identities, or service identity, or channel identities, or peer identities. All these things are the same thing. And these are ingress, front-end, back-end, health service. These are the identities that I talked about previously. But at the beginning of the request, you also have another identity, which is the original requester identity. And that can be, for example, Bob checking his Gmail on his phone. And it's very important for this original requester identity to be forwarded along the chain from ingress to the database, because at the end of the chain, it's Bob's data that we want to retrieve from the database. And let's see how this can work hand in hand with the peer identities. Along the chain, each workload can decide which peer identities are allowed to present such original requester identities. And here, for example, from the database point of view, the database can say, hey, it's perfectly legitimate for the backend to present me with an original requester identity. But a host service, which is just there to make sure that I'm alive, this one is certainly not privileged to present me with an end-user identity. The fifth principle, which is going to be the last here, and that's probably the most important one, is that your platform must implements security by default. And if you see this diagram here, you have what is provided by the platform, which is at the bottom, and the application logic, which is at the top. The platform supplies service A and service B with credentials, with an identity, automatically, without the application having to think about it, without the application developer having to think about that, you know, there's some magic key distribution going on here. It just happens. When A wants to call the getInfo method on B, again, just by virtue of using the RPC framework, automatically a channel is created, a mutually authenticated channel, that will now say that the caller is A service and the callee is B service. And the service owners are going to be able to configure some authorization checks here. For example, service B can say, identity A service can access B.getInfo. And since this is the case here, the call is going to be able to go through. But again, all this happens at the platform level without the involvement of the application logic. And that's really important. Now, there may be some types of authorization that really need some context from the request itself. And such applications are typically heavily multi-tenant. So if you want an example, you can think of a file or directory service, right? Depending on the path that is in the request, you will want to apply one type of authorization versus another type of authorization, depending on the path. And but even for these types of application-driven authorization checks, fine-grained access, we want to provide frameworks for that. And internally, Google IAM is a good way, a good framework for achieving this. So let's recap here the 5 principles that we talked about. So the first one is protect your network at the edge. Second one is to use credentials-backed identities for all the entities on the network. The third one is to use channel-bound credentials for authenticating services. 4, to grant access based on multiple identities if this is applicable. You don't always have multiple identities, but if you do, you need to grant access based on that. And the 5th one, and the most important one again, is that the platform implements security by default. And I cannot stress that enough. If there's one thing that I want you to take away from this talk is the role of the platform for security. Like, don't let each team in your organization reinvent the wheel, reinvent its own framework. Like, settle on one thing and make it better over time. So Istio security has been informed by all these principles. And now Samrat will tell you how these principles are being implemented in Istio.
Thank you, Julien. Julien outlaid some very important principles about how we at Google protect our production environment against some fairly sophisticated attacks. Right? And increasingly, we find as enterprises get more digitized and move to cloud platforms, enterprises are exposed to similar sort of threats that Google has been exposed to over the years. And we feel that it's increasingly relevant that enterprises adopt such principles to protect their own production environment. However, one of the big challenges here is, I'm sure all of you realized what Julien presented was technically complex. Right? It's non-trivial to do this in any shape or form in an enterprise environment. Right? And one of the things immediately that strikes you when Julien presents something like this was that, how does this apply to my production environment? It doesn't look anything like Google's production environment at all. Right? The problem is not hundreds of millions of endpoints. It's not scale. The problem is heterogeneity. Right? I have different workloads from different generations using different protocols, using different languages, all sitting within my data center. There is no uniform deployment model, right? They're across different kinds of runtimes. There is no standard application frameworks like the kind Julien described, right? Because it's been acquired over time across various third-party software in many cases. So this new security approach, which was described elegantly, is actually very technically complex to roll out in my environment, right? And lastly, even if I do attempt to roll it out, how do I ensure the success of this? How do I measure this? How do I get a visibility in such a complex environment as how to achieve this? And as a product manager, these are the kind of problems that we landed up thinking about as to like how do we make what is really necessary from a security perspective much more accessible to the enterprise customer. Right? And with that is how we started thinking about this problem. We didn't start thinking about saying, we want to build security features for Istio. Actually, we weren't even thinking about Istio when we started off with this problem. We wanted to make these security principles and this posture more approachable, right? And we started thinking about how we can do that. And it is over time and looking at this problem in an incremental manner that we realized that having something like Istio is very important way to enable enterprises to be able to adopt these principles. So let's talk about the primitives that build up to form Istio and make this possible. Right? The first thing that you need to do, given your heterogeneous infrastructure and the fact that you have all kinds of protocols and languages, is the ability to virtualize this application network endpoint. Right? And Envoy as a sidecar was something that our senior technical leads did a long evaluation across a bunch of models, and they came up and said, this is the most optimal way of achieving this goal. Right? And so that gives us this abstraction. In addition to, so a key thing about that abstraction is now you can start being transparent to your application code, because this now becomes your policy enforcement point, right? And as well as policy monitoring and network monitoring point, right? So now you certainly have something that is the equivalent of a NIC card, but at the application level, right? That gives you all these properties. Right? Another key feature which we did invest in Envoy was to make sure that the TCP support was more robust, because this is one of the key things that differentiates a homogeneous infrastructure that's all RESTful to something that is more enterprise-like. Right? And so with this in place, you can now have uniform policy enforcement, and you can have uniform access metrics and logs. The second question you might ask is, I get the value of Envoy, I get the value of having a proxy. But why do I need a service mesh? What is this service mesh? I know I have a mess in my production environment. Do I really need a mesh on top of that? So it's, yeah, the name mesh is a bit of a marketing play, right? What it really is a way to virtualize your network at the application level to some extent, right? And in order to do that, you actually need, just like with any other networking software, or you need a control plane, right? And you need a control plane that can scale to thousands of services. And just like any other networking system, you need to have a central policy control, a central policy visibility, and you need to way to have a notion of being able to reason about who is talking to whom, right? And you're able to do that at the L3 level with your tools, and you must be able to do that at this level, right? And how do we achieve that? The proxies by themselves are not enough, right? And Istio really solves for those problems, right? So we chose Istio not because it's a cool thing, but because it actually solves a real problem from a security perspective. So going forward, Istio does more than just security, obviously. For those who are familiar with it, it does traffic management, like load balancing, as well as things like ability to route with layer 7 semantics. Of course, it does security, and we'll deep dive into that today a little bit more. And it does telemetry, which allows you to get various kinds of signals around performance and error rates to make sure that your services are more reliable and performant. So we go back and look at those 5 principles and how you can apply them using the technologies that we provide on Google Cloud and through Istio. So the first is about protecting your VPC. In the context of cloud, your production environment can be represented as your VPC, right? And how do you protect that at the edge? There are 2 main things to achieve here. There are 2 things to do here. One is to protect your public-facing endpoints, right? And protect them against internet-based threats. So we provide a couple of technologies there which are very powerful. One is Cloud Armor. Julien talked about DDoS protection. Cloud Armor allows you to, it's sort of a sophisticated WAF, which also has DDoS protection baked in, right? So this is a critical piece of your front-end strategy. The second is, Julien talked a bit about how we have an admin proxy to allow beyond COP-like principles in order to grant access for employees to gain access to production systems. We have built a corresponding thing called identity-aware proxy, right? Which allows you such, it's a good way to allow humans and to secure human-based access to the production environment. Having protected the front end, you think of the perimeter. Actually, the perimeter is not just what's facing the internet. In many cases, your perimeter may be a departmental boundary that you wish to draw within your network sometimes. Or in Kubernetes landscape, we call those clusters or namespaces, right? In your other environments, you might call it a network segment. You need to protect that against other parts of your network that don't have the same level of sensitivity, security sensitivity. So this internal segmentation is also needed. And Istio Ingress is a solution for that because it can act both as a layer 4 as well as a layer 7 sort of a proxy in order to segment two different pieces of your infrastructure. And then once you have this front end protected, you need to now seal out the perimeter. Right? And that means defending against exfiltration vectors and control. So one of the things we provide is firewall policies. Like these are layer 3 policies to understand, to be able to control outbound communication from within your network. And now what is just GA is VPC service controls, which is a way to extend this notion of a secure perimeter to multi-tenant cloud services like GCS and BigQuery, so that you can implement a similar perimeter strategy for those as well. So this is a diagrammatic view of what I just talked about, right? So as you can see here, from a corporate network, you can gain access through identity-aware proxy. You have Cloud Armor in front. And these are actually implemented on Google's Cloud's load balancer. So they are effectively policy engine, both identity-aware proxy and Cloud Armor on Google Cloud load balancer, right? Additionally, you can now implement an Istio Ingress that sits right behind it to provide additional segmentation. So let's take the second principle, using credentials-backed identities for all entities on your network. Now, Julien talked about having ALTS as being the source of truth to provide, and the certificate manager to provide identities to everything, administrators, hosts, and workloads. In your enterprise, typically, it's very hard to have this kind of a uniform way of meaning trust. Assigning trust to users and to hosts is typically a solved problem in most production environments. You have been doing this for many years. Right? What is really unsolved as a problem is a way to assign identities in a secure manner to the workloads. So this is what Istio is trying to solve. It tries to complement what you already have and add to that by providing a certificate authority for workloads, which is different from necessarily the roots of trust that you might use to, say, identify your users, which might be an Active Directory, or identify your host, which, and in this particular example, that could be the Kubernetes master, which is able to determine the trustworthiness of a node on which it is deployed. So in this particular example, taking the same example that Julien gave, but now applying it to Kubernetes, you have Alice, who's on a corporate workstation trying to deploy a pod to a Kubernetes cluster. Right? In this particular case, Alice authenticates to the cluster, to the master, and perhaps as a particular namespace admin with deployment privileges in order to be able to deploy. So therefore, we know she has the right privileges in order to start doodle.frontend over here. Right? At this point, once she's authenticated, the master can then deploy the Doodle frontend, and it assigns an identity, which we call a service account. Right? So service accounts are now becoming a common parlance. It's used in Google Cloud Platform, AWS, and Kubernetes. They basically represent an identity that is typically associated with your workload. So at this point, once it's deployed, if this workload were to be part of an Istio-enabled environment, then there's a node manager which is running on that particular node that then is able to use this identity that was just issued by the master and create a CSR, or a certificate request, to the service mesh certificate authority, right? And the service mesh certificate authority now takes this identity and encodes it into a X509 credential that is then placed, that is provided to Google Doodle frontend for authentication. Traditional X509 certificates authenticated hosts. So we worked with the open source community to come up with a way that everybody agrees on, at least within the open source community, of encoding a workload identity into an X509 certificate. This is called spiffy, and the format that we all agreed upon was how it would be encoded in X519. And Istio supports that and is able to interplay with any other party that can also support the spiffy format for certificates. Going to the third principle, using channel-bound credentials for authenticating services. Julien touched upon this lightly. I will give a concrete example to make this real, right? You can, with Istio, specify a policy that says all communications to service B must be authenticated over mutual TLS, right? As in, when we talk about channel bound, I'll cover that one more time. The identity actually must be a certificate on the channel, right? Such that that identity cannot be replayed. So in this particular example, assuming the shared service, the logging service was compromised, if you're only allowing mutual TLS-based identities for authentication, then even if service A were to present its certificate to the logging service, the certificate by itself cannot be replayed because logging service cannot create a channel, right, a TLS channel, with the private keys that correspond to the certificate, right? So this is a very key principle in order for us to mitigate risk and escalation of privileges associated with impersonation, right? So thus, all peers, once you enable this mutual TLS, we can guarantee that all peers are authenticated using certificates-based spiffy credentials that are channel-bound. However, this is easier said than done for your brownfield applications, right? Imagine a world where you have an existing service. You turn on MTLS. Voila, here's some bunch of phones ringing because a whole lot of clients which you didn't know existed weren't enabled for MTLS, and they just broke. Right? So it's very hard to actually do this in practice. So one of the things we did in Istio was to create this mode called permissive mode. In the permissive mode, when you set it to permissive mode, a server can accept both mutual TLS authenticated clients as well as your existing clients. So thus, what we would recommend for your brownfield applications is you set all your services to this permissive mode, which is now the default mode for Istio. And then you ensure that all your clients are talking MTLS. At some point, you are able to determine that all clients talking to a service are now mutual TLS enabled. And at that point, you can lock this service down by changing it to a strict mode. We talked about the identity of origin earlier, right? And we must be able to propagate that as a forwardable credential, right? So in the cloud environment, for example, you can use identity-aware proxy to authenticate any human coming from a portable device. You can use certain principles like which device type, etc., when authenticating to identity-aware proxy, right? So those checks can be done in order to grant access. Now, all this context that is part of the client context, what identity-aware proxy does is it encodes it in a token, which we call RC token. It's a form of JSON web token that has been structured specifically with we provide greater structure. And very importantly, it's a short-lived token. This reduces insider risk because if the token is logged or is stolen, we are reducing the risk by reducing the time for which it is valid. Right? Where Istio adds value in this process is being able to able to validate that this token is actually a valid token by contacting the issuer and validating the fact that it's a valid token, such that the backend can now safely use the claims in order to grant access or influence business behavior. Right? And thus, as you can see, Istio is taking care of a lot of the plumbing that you would normally have to do in these particular cases. Going back to the fourth principle, which is granting access based on multiple identities. Right? The main reason to do this is to protect user data. So many of you might be handling data of your customers, and this is the reason you want to do this, not for any other reason. It's not a traditional network security posture. It's more about user data, protecting that through access control. Let's take this example where there's a privileged insider, for example, a support engineer, who can access, based upon real business requirements, your user data or your customer data, right? But what you really want the support engineer to do is to only be able to access the data via the case tool. Because the case tool implements a lot of your business policies. Like, for example, is there a valid support ticket against this, right? Is the support engineer properly logged into the system? Are we logging all accesses? So on and so forth, right? If you're able to bypass this tool, then you're able to bypass all those checks, right? But at the same time, the case tool might be a tool that is delivered by a bunch of your developers internally or a third-party software which is deployed by somebody else. The people who have the deployment privileges on the case tool need not have access to the data. Imagine a financial services or financial records. The person who runs the job may not be an insider to get your quarterly report, right? But they have the admin privileges to deploy their job, right? Here, this is an example in support. That's another example in the sort of a FR kind of world, right? So, which means there are two things that must be true. The access must come from the case tool, and the authenticated user, which it is acting on behalf of, right, must be a support engineer, right? These two things must be true in order to grant access. Thus, you have to reason about both of these identities in order to grant access, such that this privileged insider cannot create an unauthorized client and simply access because only the user was authorized or was on the policy. Similarly, the case tool cannot identify itself and in using its ambient authority have broad access to the data, because that's a sure way of getting increasing an insider risk, right? So therefore, it must be working under the delegated authority of a customer support engineer, right? And this is a very key reason why we need to create yet another policy engine for Istio and not simply rely on existing network policy engines that exist in Kubernetes and outside, right? This is not a solved problem. Now, it's a new policy language that we are building, and we will continue to work on this, right, over time. But this is the primary use case that we are targeting, right? There's multiple channels through which different users can access for different use cases, right? And how do we make it easy for you to be able to build such policies and implement user data protection within your production environment? So we talked a lot about two identities and the origin identities, and you might wonder, what about non-HTTP service interactions like MySQL, for example? And the answer is, that's true. We cannot reason about the identity on the at the SQL protocol level, because today Envoy doesn't understand it. Hopefully, over time, we want to increase the number of layer 7 protocols that we understand. But today, we are limited to HTTP, gRPC as the primary protocols that we support, right? So in such cases, yes, we are not able to reason so strongly about who is the user on behalf of which the call is coming from. But we can still constrain which are the people from which any access can be presented from. So for example, even if you have the MySQL credentials, you should not be able to access the database from anywhere except through service A, right? And we can enforce that property, right? So no matter what, like if your MySQL credentials were stolen, or it was in a source control system somewhere and somebody accessed it, they will still not gain access because they have to go through service A. And that is still being enforced. So there's still a win for TCP communications outside of where we don't understand the layer 7 protocol. The last part is platform implements security by default. Throughout this talk, you might realize that I've kept talking about how Istio implements all of these. I've never said how your application needs to change in order to adopt any of this posture. All of this complex technological paradigms are all expressed as policies that get enforced at the proxy level, right? So these include encryption of data in transit. It includes the ability to auto-rotate certs and keys. A very hard problem, actually, to do this at scale, right, and do it properly. So to ensure that you have the right cryptographic hygiene. How do you protect user data access using both identities, right? This has been traditionally been a hard problem to enforce consistently across. And how do you monitor security posture consistently across your heterogeneous environment, right? Now you have the ability to do all of that because you're able to use something like Istio. The last point deserves a little more attention since I did not cover it before. And it's important to understand that in a new world, let's say you have a MapReduce workload that comes up on a bunch of containers, access your sensitive data as a bad job, and then disappears. It was a bad job. You go back, look at your network flow logs a week later, a month later, and try to explain to your internal and external auditors what just happened. A bunch of IPs showed up, contacted this backend IP, and then a bunch of IPs again showed up, new IPs that contacted something else. And we have no idea what that IP actually meant, because it's a completely different workload that ran in different points in time, right? Now you can actually have logs that has an identity for that workload, not of the host, right? And you're now able to have this visibility across a heterogeneous set of environments, heterogeneous set of protocols, including the TCP protocol, which I just explained. Who accessed the MySQL database is still expressible as an identity, right? So you're able to do that, right? So you're able to understand that, and it makes your network access logs much more meaningful in this new environment, and it helps you go through your security and compliance audits much more easily, right? And you're able to do this in a consistent manner independent of your infrastructure. So with that, I would like to just explain how you can get started, if this is something that is of interest to you, how you can get engaged. To start with, I would strongly recommend that you read our infrastructure security papers, and in particularly the application transport security paper, so that you have a deeper understanding of how this actually works at a deep technical level. And then to engage on Istio, you can start by reading the blogs and going to our website, which has the concepts, a bunch of examples, and how to get started in open source. On Google Cloud, we have an Istio on GKE, which is sort of makes it much more easy for you to just get started. So strongly recommend that as a way to get started on a hands-on basis. If you want to know more about what we are doing as Google secret sauce around Istio, please reach out to me at samratray@google.com, right? And I'm happy to sort of help work with you to give you more information about what we are doing to make this much more magical for you. So thank you all for taking the time and having the patience to go through a fairly technically complex topic. I hope this was a good use of your time. And there's a lot of interesting talks about service mesh that have happened during Next. Some have already occurred. Some are coming up. Please feel free to attend those which are coming up, and or go and look at the videos for those which have already occurred if you haven't attended them already. Your feedback is greatly appreciated. We don't have a moderator for the Dory, but if you do ask questions, we can on the Dory, we can certainly look at it and come back to you offline. In the meanwhile, we have a few minutes, like 4 minutes, so if anybody has a few questions, we can take a couple of questions right now.